Avi Loeb is a professor of science at the prestigious Harvard University. Some of his main interests include astrophysics, cosmology, and the search for extraterrestrial intelligence. He's the founder and head of the Galileo Project, a non-profit with the goal of searching for extraterrestrial technological signatures of extraterrestrial technological civilizations. Avi has a PhD in plasma physics, an H-index of 127, and has published around 1,000 articles and 8 books. He was previously the longest-serving chair of Harvard's Department of Astronomy. This is my third interview with Avi. Scroll into the description for timestamps, extra info, and useful links. And if you enjoy this video, please like, comment, and share. Thank you. Thank you so much for doing this with me, Avi. I really appreciate it. Our third annual interview. To begin this time, I wanted to ask you about your own highlights over the last year since we last spoke.
It's great pleasure to join you, Ben. And there were lots of interesting developments. Most importantly, a year ago, we went to the Pacific Ocean, to the site of the fireball of the first recognized interstellar meteor. It was 0.5 meter in size, collided with Earth, and released in the explosion a few percent of the Hiroshima atomic bomb energy. But most importantly, US government satellites detected its motion and measured the speed at which it was moving. And together with my student, Amir Siraj, we realized that, in fact, this object was moving faster than the escape speed from the solar system. It was moving at 45 kilometers per second relative to Earth, but it was coming from behind the motion of the Earth around the sun. And so relative to the sun, it was actually moving at 75 kilometers per second, more or less. And that is well above the speed needed to escape from the solar system, meaning that it came from interstellar space. There was another meteor, actually just a few months ago, detected over Spain and Portugal. And that one was moving also at 40 kilometers per second. And so someone wrote to me and said, is that interstellar as well? As it turns out, this other meteor, the more recent one, actually came from a direction that is opposite to the motion of the Earth around the sun. So it collided with Earth face on, so to speak. And the fact that it was moving at 40 kilometers per second relative to Earth is mostly because of the motion of the Earth around the sun at 30 kilometers per second. So it was definitely from the solar system, came from most likely the proximity to Jupiter. It was from the main asteroid belt. So this second one is definitely from the solar system, but the one from January 8th, 2014, more than a decade ago, came from interstellar space. And we went there because it exploded. This one, the interstellar meteor, exploded 20 kilometers above the Pacific Ocean. And the one over Spain and Portugal exploded at an altitude of 70 kilometers, where the density of air is 1,000 times lower for that Spanish-Portuguese meteor. So that means that the material strength of the recent meteor is 1,000 times lower than the one that came from interstellar space. And that suggested to me, at least, that it could be artificial in origin. That imagine the Tesla Roadster car that Elon Musk launched in 2018 as a dummy payload on the Falcon Heavy. That car is now on an elliptic orbit around the sun. And in 20 million years, it has a 20% chance of colliding with Earth. And if it will collide with Earth, it would appear as a meteor of a very unusual material strength, actually, because it's made of steel. And we might recover some big part of it once it goes through the atmosphere. So I just wanted to check the materials at the site of the interstellar meteor, and we went on an expedition, and it lasted 2 weeks. It cost $1.5 million. We collected materials, brought them back to our laboratories at Harvard University and at the Bruker Corporation in Berlin, Germany, and analyzed those materials and found a small fraction of molten droplets that had a chemical composition different from solar system materials. And we wrote an extensive report about it, submitted it to a peer-reviewed scientific journal. It was already reviewed once, and we're waiting after making the adjustments following the constructive reports from the referees. We are waiting for the final decision by the journal. And that was very exciting because that's the way science should be done. There is an interesting data that appears anomalous. In this case, the material strength was unusual. This object was actually outside the solar system, was moving at 60 kilometers per second, and relative to the local standard of rest. And that is faster than 95% of all the stars near the sun. So there was a very interesting puzzle about the origin of this object. It could be natural, and I published a paper just a month ago about the possible natural origin. If you imagine a planet like the Earth coming close to the most common star, that's a dwarf star that is 10% of the mass of the sun, 10% of the radius of the sun. Such a star is so dense, it's 100 times denser than the sun, that if a planet like the Earth comes close to it, it will rip it apart by the tidal force and will basically spaghettify the planet and eject rocks from the planet into interstellar space. And we calculated in this paper that the speed can naturally be 60 kilometers per second, like this meteor was. And moreover, the chemical composition might be very different because the rocks are melted when they pass very close to the star. So that's a possible natural origin, but it could still be technological in origin. And if you take your laptop and throw it into a fireplace, just from the molten droplets that you get, you will not be able to tell that it's technological in origin. You need a big piece from the screen of that computer to figure out that it was indeed artificial. So we are aiming to go back to that site in the coming year and collect bigger pieces from the wreckage of this meteor. That expedition will cost $6.5 million, and it will use a robot that we will put on the ocean floor that will give us a video feed of everything we see, so we can in real time navigate it and get what we want. And if we find bigger pieces, that they will tell us the story about the origin and the nature of this meteor. So that's very exciting. But in addition, we have also an observatory that we built at Harvard University in the context of the Galileo Project that I'm leading. And over the past 6 months, we collected data from the sky of about 500,000 objects. We are now analyzing this data using machine learning software. So far, we haven't detected anything anomalous among all these objects. But just yesterday, I was looking at results from the machine learning, the artificial intelligence analysis, and actually the computer is able to identify objects that by eye we miss. And so that brings in the possibility that we might find something anomalous once we go over the entire data with the artificial intelligence software. So stay tuned. We are in the process of writing papers reporting about these results. Hopefully we'll get most of the work done during the summer. And then it's the first time that a very systematic study of the sky was done over a long period of time. Because in the past, reports about anomalous objects were, they were anecdotal, that people happened to be at the right place at the right time. And we did the first systematic study over a period of at least half a year by now. We're also planning to build 2 additional observatories, one in Colorado, the other one in Pennsylvania. So altogether, hopefully within a year, we'll have 3 looking at the sky. So both of these developments are very exciting. And that's all in the context of the Galileo project. Of course, there are some exciting results that I did in my scientific work that I arrived at that have nothing to do with the search for an intelligent civilization out there. But if you want, we can talk about them later.
Yeah, sure. I mean, whenever you feel like you want to share them, I'm always interested to hear. We don't absolutely. It's not just good to hear about stuff that relates to the search, although obviously that is an incredible source of curiosity for me, probably most of the listeners, and of course you. Did you want to talk about them now? Or would you rather I circle back later?
Well, I'll just give you an example for
Sure.
something that happened this week. Just actually a couple of days ago, there was a paper published by in the Astrophysical Journal, and it reported about the properties of one of the puzzling results from the Webb telescope. These are little red dots that were found in deep images from the Webb telescope, and they correspond to very compact galaxies, red galaxies that exist at cosmic dawn, at a very early phase in the evolution of the universe, more than 13 billion years from the present time, if you go back in time. So these galaxies existed less than 800 million years after the Big Bang. And what we see are very compact galaxies where the light is emitted from a scale that is smaller by a factor of 20 to 100 than you would expect for a galaxy like the Milky Way. And they contain as many stars as the Milky Way galaxy, and from a very small region. And they appear to be red beyond the cosmological redshift that we expect. And so probably there is some veil of dust that makes them red. And there is a strong suspicion that they have a massive black hole at the center in their belly. So they're pregnant with a massive black hole. And the question is, what are these things? And I was reminded when I heard about it, I read the paper that just came out, and I realized that in fact 30 years ago, when I just came to Harvard, a young student showed up in my office. His name is Daniel Eisenstein, and he came from the physics department and asked me to mentor him. He asked, "Could I be your student?" And that was just upon my arrival to Harvard 30 years ago. And I said, of course. And then I gave him a project that we can work on. And the idea was that, out of the population of galaxies, the size of galaxies is dictated by the amount of spin that they get when they form. And they get their spin, their rotation, from torques that are exerted on them by their environment. But because galaxies form in many different environments, you will get a distribution of torques, a distribution of spins to galaxies. And the smaller the spin is, the more compact is the disk of gas that you will get when the gas cools towards the center of the galaxy until it's held against gravity by rotation. And so the idea was that there is a tail to the distribution of galaxies with very low spin. And so those particular galaxies would have very compact disks, and those disks could feed a black hole. And so that was a prediction from 30 years ago, and now I connected the dots, literally speaking, in the context of these little red dots.
Yeah.
One way to think of them is rubies, red rubies. They were used, they were put on necklaces back by Europeans, in the Middle Ages, because they were thought to be a source of luck, or promote the prosperity, health, love, and so forth. And so when you see these red rubies in the sky, it's inspiring in some sense. But I realized that in fact they could be the low spin galaxies that I was talking about from 30 years ago. So I wrote a paper the same day about it and submitted it for publication. This is just an example for a situation where the idea predated the discovery, And very often, after 30 years, scientists forget about papers that were written. Most of them are not remembered because many of the young scientists were never around at the time that the paper was written. But gladly, I have this long scientific memory, so I connected the dots in
Yeah.
this case.
That's awesome, and that must have felt good. I was reading you wrote about it in your Medium as well, and I was reading a bit of that,
Right.
and I also had the thought at the time. I was like, how does Avi manage to find the time to do all of this stuff? Like, it's just unbelievable. You must be incredibly good at managing your time, I think.
Well, yesterday I was interviewed by a young student for a podcast, and the student asked me, why is science exciting? Why should that be a choice that any of us makes to pursue science? And I said, it's really thrilling to understand something that nobody else understood about the universe. That's what motivates me, and that's what gives me joy.
Yeah.
I don't enjoy going on a vacation, sitting on the beach forever. That is boring at some point because I have ideas, I have thoughts bubbling in my head, and maybe it's just me, but I personally get my, the meaning for my life out of understanding the world, trying to figure out. There are lots of things. I mean, most of the stuff we don't understand. Starting from the fact that, when we are born, we are given our body as if we got a car from a dealership. We are not responsible for designing our brain, for designing our liver, heart. In fact, we don't even see these organs. So it's sort of like driving a car. You haven't seen the engine. And what really surprises me is that a lot of people, after driving the car for a while, they get their pride out of the performance of the car. Okay, so a lot of people develop an ego. They get attached to themselves as if they're supposed to be credited for whatever they're able to do. I mean, sure, there is some decision of where to take the car and which road to drive and how fast to drive the car. But these, in my mind, are secondary to the ability of the car to drive fast, like the ability of your brain to think. Or if you're into sports, the ability of your muscles to power you in a way that is better than others. And I just don't understand why people are so attached to their ego, because the ego is really the source of all evils. In academia, it makes people arrogant. It makes them not curious because they want to maintain their stature and they want to get honors and awards. They create, echo chambers around themselves with young people repeating their mantras. And that is only driven by their ego. If they were curious the way they were at a young age, they would be willing to make mistakes, to take risks. So I think it suppresses innovation in science, in academia, and it also discourages other people from exploring the unknown because they are worried about the consequences. If they were to say anything that deviates from the beaten path, they might get punished. They will not get jobs. So that is very bad in academia. I'm trying to obviously change it by showing an example of. But of course, in my stage of my career, I'm not really afraid of anyone. I don't subscribe to social media. I don't care how many likes I get. And I'm just driven by my curiosity. And that's what really, I think, is the fundamental reason to pursue science. Because, the knowledge we have is just an island in an ocean of ignorance. And there is a lot to learn.
Yeah.
And it could be of great benefit in the future. Just think about maybe 1,000 years from now. Suppose we have a theory that unifies quantum mechanics and gravity. Then we might be able to understand how the Big Bang started. And then we might be able to even engineer that and create a baby universe in the laboratory. And so creating a baby universe in the laboratory, if we are able to do that, we can apply for the job of God. If you ask what is the job description of God, the biggest requirement is you should be able to create a universe.
Yeah.
And if a scientist can do that,
it
means that we can apply for that. But you might say, oh, that's very arrogant. I say, no, it's not arrogant. In fact, the more you understand, the more you realize how much you don't understand and how much you are a small piece of a much bigger thing. Okay.
Mm-hmm.
Because the only way to be arrogant is when you focus your attention on your immediate environment and you can be better than anyone else within that environment and you feel good about yourself. But once you realize how big the universe is, you realize how much you don't understand and how much is left for you to figure out. It brings humility, actually. It's the other way around. And then, of course, if you keep understanding more and more, you're able to accomplish more. But still, you recognize your limitations. And so, I think it's a process that could last forever for us to understand everything around us. And I would be happy to live forever in order to continue to do that. So, there is a Netflix documentary team that is making a documentary, should come out by the end of 2025 about my research. And I had a public appearance on Capitol Hill. I had an event just a few weeks ago, and they were there. And after the event, they interviewed me on the roof of a building near Capitol Hill. And the question that I was asked is, what is my greatest wish? And I said, well, I would like to live forever. I would like to be immortal. And so the director said, isn't that arrogant? And I said, not at all. I mean, I'm doing it because, that would allow me to try to understand the world much better, because there are so many questions that we don't have answered. And it actually, the more I learn, the more modest I become, because I realize that I'm just a small part in a much bigger thing, And so it's exactly the opposite of being arrogant. It's the recognition that we have a lot to learn, and the more we understand, the more modest we become.
Yeah. Yeah, absolutely. And you'll get to be around for the first contact, if the first official contact with an extraterrestrial or non-human species would be fun too.
Yeah, I mean, if I knew that there is no way out and I will die, I would actually be happy to get a one-way ticket out of this earth at this point in my life, because I've seen a lot of things on Earth, and I would like to explore the unknown, and I'm happy to go out there. And meeting someone from another star is actually amazing, because it's much better than having a date using an app. Because if you try to find a date on Earth, it's probably another, it's obviously another human with the same traits, the same DNA, and but if you meet a partner from another star, all bets are off, because the circumstances for that partner could have been very different. So we shouldn't assume anything. And I would be just thrilled to learn from a smarter partner, a smarter neighbor out there. Because it's just fun. It's an adventure.
Yeah, absolutely. So there was like 1,000 things I would want to ask you about all the stuff you've said so far. So I'll try and kind of narrow in on a few, but absolutely agree about science being the search for the unanswered questions, and the more that we learn, the more questions arise. Absolutely.
On that, just before you ask your question on that, I should add that we are usually driven by the known unknowns. In the words of Donald Rumsfeld, who spoke about defense-related issues, but here I'm talking about science. So there are things that we know that we don't know, like the nature of dark matter, most of the matter in the universe. But the most fascinating things are the unknown unknowns. So these are things that we don't even realize that we don't know.
Yeah. Yeah, absolutely. That's thought-provoking stuff. I also loved your metaphor of the car. By the way, that was that's a great metaphor as it regards to like the what we're given at birth and that kind of thing. Some people have the full package. They get very lucky. Some people just have good cornering. Some people have good brakes. Some people have the acceleration, and some people have a great everything, but they have terrible roads in their country. They're born into a horrible situation.
True.
So it's a great metaphor. To go back to one of the things, I'm going to pick one of the things that you talked about in that kind of opening description of all of that. The spherules, I wanted to ask you a question about them, and as well the expedition, because that was something that we talked about last time. I think you were going to go on the expedition maybe a few weeks after we spoke last time. So kind of part A would be, what was that expedition like, and was there anything kind of noteworthy that you wanted to share that happened out there? And secondly, I've got a quote from a paper about it that I found and wanted to just kind of get you to translate into layman's terms. So the BELAU type spherules reflect a highly differentiated, extremely evolved composition of an unknown source. So you've already said that they could be natural, could be engineered or technological, but yeah, could you kind of elaborate on what that means and how unknown, in what way they're unknown and all that kind of thing?
Yeah, so first, it was an amazing experience because I'm a theoretical physicist. I was trained as a theorist, and I worked mostly in the realm of ideas, proposing ideas. When I started the astrophysics, I was offered a 5-year fellowship at the Institute for Advanced Studies at Princeton under the condition that I'll switch to astrophysics. And then my mentor there, John Bacall, he asked me, what kind of computer programs do you know? And I said, I'm using Fortran back then, and I'm just using it very minimally to solve a set of differential equations when needed, but otherwise I avoid the computer as much as I can. And back then it was 1986, okay? And he said, how is it possible for you to have a career and finish a PhD with so limited knowledge of computer languages? And he was just puzzled that I'm able to thrive. And now it's already 40 years later, and almost 40 years, and I still had a very successful career with over 1,000 scientific papers, 9 books, and so forth. And the main reason is that I just happen to have ideas that nobody else has at the time, and they come to me very naturally. Some young person comes to my office and describes the work they're doing, and I ask a few questions. Turns out that they haven't thought about that, and they then work for years after that conversation on a subject that they did not realize connects to what they're doing. And it just occurs to me naturally. It's not a big effort, and for me it's straightforward, and it's just a matter of luck that the same quality is not shared by many people. If it was shared, I wouldn't be in my position, because there would be many other people that do the same. So anyway, I was trained as a theorist, and that's the way I worked for many decades. But in this context of the meteor, I realized if I don't do the experimental work of collecting the materials, nobody else will do it. And it's really important. So I led this expedition, and it was an experimental project. We had to go there. So you need to build the tools. You have to build a sled with magnets on both sides, design it. So you have to assemble a group of people that are engineers knowing how to do that. You need to put to have a navigator, a person that coordinates the expedition, that knows how to rent a ship, to get the permissions, to put all the equipment on the ship, to have a team of workers, that includes a cook and so there are lots of ingredients here, and then to get the funding for this, and then to know where to go, and then to if you find the materials, to know how to analyze them, because it's a subject that is experimental, and you need to analyze it with mass spectrometers and electron microscopes and so forth. And this is experimental work, so you need the best experts in the world. And then when you get the data, the results, you need to analyze it and compare it to existing literature, which is experimental, and so there are lots of ingredients here. It's a very complex operation, actually, especially for someone who was never an experimentalist like myself. But the amazing thing is that I was very lucky to recruit a team of exceptional individuals, the best in the world. And I'm not just exaggerating it. Actually, we had the best coordinator, Rob McCallum, in the world. If I ask people at random if they know him, they will tell you that. I mean, he works for decades. He worked on the Titanic. So, he worked with Jim Cameron for decades. And he just came to the porch of my home and asked if he can help us with the expedition.
Wow.
And then he brought in a team of engineers that worked with him, and I had the contacts with other people before that. We had an exceptional navigator, 86 years old, Art Wright, who had a lot of experience in missions like that, and was actually the commander of a destroyer during the Vietnam War. I spent the years in academia. I would never, have met people like that. And then then the ship and the permits and everything, and eventually analyzing the materials with colleagues like Stein Jacobson at Harvard or Roald Tagel. These are people that I didn't know before the expedition. So it was a non-trivial project that could have failed easily. There are lots of failure points. We could have not designed the correct tools. We could have gone to the wrong place. We could have not found materials. We could have not had access to the best mass spectrometers and X-ray spectrometers, spectrographs, or electron microscopes that the world has to offer. We could have not surveyed enough ground on the ocean floor. There are lots of failure points, but the amazing thing is that the mission was successful. We retrieved materials by a factor of 10 more than a typical expedition in the past for meteoritic materials. And if you look at our paper, you will see a lot of diagrams that are really state of the art. For example, just for comparison, there was the OSIRIS-REx mission that NASA invested $800 million in, and it went to the asteroid Bennu and landed on it, collected materials, and brought it back to Earth. And in April 2024, just a few months ago, the team of researchers that analyzed this material released their findings. And if you look at their paper, it's in terms of details, it actually has less details than we have, or comparable amount of details than we have in our paper for an expedition that cost 500 times less money. And it just shows to me, because their paper appeared after ours, it shows that we did really the very best possible work in analyzing those materials, because we are reaching the same level of analysis as this $800 million endeavor that NASA funded. And so it was an amazing experience. And of course, for also being there, I didn't sleep much for 2 weeks, because we had 26 runs where we would collect materials from the ocean floor for 8 hours, bring it back to the deck of the ship, and then scrub the material off the magnets. And they would wake me up as the chief scientist, even if it's in the middle of night. And I would sleep on a sofa in the conference room and just wake up whenever something came out. And I also wrote the diary reports on medium.com, and they were read by millions of people around the world in real time. They were translated to Spanish. I got an email in the middle of the trip that from a person in Denmark that said that he just had a stroke, and he's writing from the hospital, and reading my diary reports gave him reason to live longer, and because he really is inspired by the scientific work that we're doing. That was very touching, very rewarding for me to read. And I got a lot of emails like that from young people inspired to do science and so forth. So, and I would jog every morning at sunrise the way I do on land. And the one funny anecdote is that my workout app showed me on the first few days that I'm actually jogging slower than usual. And I was worried that it may be the jet lag, maybe I didn't sleep enough. But then I realized that after a few days that in fact it's my watch is measuring the speed of the ship, the boat, rather than my speed, because it's based on GPS, the location of the ship. And so that calmed me. And the Netflix documentary team was there one morning filming me as I jog, even with a drone. They put a drone that is looking at the ship from a distance. And they asked me to jog 3 times longer than usual. So it was an hour and a half that I jogged for about 9 miles. And then at the end, the director said, Avi, it looks like you're running. Are you running away from something or towards something? And I said, both. I'm running away from some of my colleagues who have strong opinions without seeking evidence. And I'm running towards a higher intelligence in interstellar space. So that was, altogether very uplifting and an amazing experience, and I hope to do it again with the next expedition. Now, regarding the analysis of the chemical composition of those molten droplets, we used the mass spectrometer in the laboratory of Stein Jacobson, a world-renowned geochemist at Harvard. And we found, we looked at 66 elements from the periodic table, and we found that a significant number of them have an abundance that is elevated relative to the standard solar composition. So in other words, the sun has some characteristic composition of chemical elements, and you find it also in what are called CI chondrites, carbonaceous chondrites that are representing the primordial material that made the solar system. And we found that some elements have abundances that are up to a factor of 1,000 bigger than this standard. Just for comparison, the Bennu, the material collected from the asteroid Bennu, that material had within a factor of a few the expected solar composition. So here is an object that is from the solar system, and it showed just what you expect, the standard solar composition. But what we found is up to 1,000 times more for elements like beryllium, lanthanum, uranium. So this kind of a composition was never reported in the scientific literature, and we decided to give it a name, Belau, because of beryllium, lanthanum, uranium that have up to 1,000 times more than the standard solar composition. And the next step for us is to analyze the isotopes that we have. It will be difficult because we don't have a lot of material, about 100 milligrams or so. That's also why we want to go again to find bigger pieces so that we have a bigger sample. Because if we can find isotopes at large quantities, we can date the material, we can figure out the age of the material and compare it to the solar system age. I should say that together with an undergraduate student this summer, I'm writing a paper about where this meteor could have come from. So we are integrating the trajectory back in time and finding that it actually came from the outer part of the Milky Way galaxy, not from the inner part. And that's very interesting. And it also came from the disk of the Milky Way, not from the halo. And that's very interesting. And the other calculation that we are doing is also asking where will Voyager, our own spacecraft, be in the future? And we find that, if you consider 1 billion years in the future, it will be actually on the other side of the Milky Way galaxy relative to the sun. And that just shows you that space trash from other civilizations could be all around us, because there was plenty of time. I mean, most stars from billions of years before the sun, there was plenty of time, if they had a technological civilization, for their trash to reach our backyard. And their trash is our treasure.
Yeah, absolutely. What you're looking for. Do you lean one way or another, or are you totally kind of open-minded on it and you're going to wait for further results? Do you lean towards natural or?
I'm open-minded. I wrote a paper saying there could be a natural origin. And by the way, I should say, it's really fascinating because in the analysis paper, the first version of it had 46 pages of details. And out of those, there was one sentence in the discussion where I said, this unusual, unfamiliar chemical composition could be from technological origin. And then I was immediately attacked in news reports for this particular sentence out of 46 pages of data. However, when I wrote a full paper on a natural origin for this meteor that was published, peer-reviewed and accepted for publication in a journal called Astronomy and Astrophysics, very prestigious journal, we had a press release about it, explaining how the properties of this meteor could be natural. No reporter picked up this story. No critic mentioned the fact that this paper exists. After it was peer-reviewed, published, and had a press release. And you ask yourself, what is really driving the news cycle? It's controversy in order to get as much clickbaits. Why aren't the critics mentioning that? Because the only way for them to virtue signal is by attacking rather than cooperating or acknowledging a useful result. And it's really unfortunate that this is the reality that we live in.
Yeah, it is unfortunate, and it affects everything. So I guess for now, your last words on the spherules would be they could be technological, but they could be natural. Yes, so absolutely open-minded.
I would say that just the chemical composition by itself is insufficient, because a lot of people said, well, uranium can be used as fuel, and beryllium can be used to moderate neutrons in nuclear reactors. And so you could imagine technological reasons for having those elements more abundant, but you could also imagine a natural source for this enhancement. And as I mentioned, I wrote a paper about it. And so to figure out the actual origin of this object, you need the bigger pieces that would actually show you whether it's a rock or a gadget.
Well, I look forward to you going back and giving us more information and finding more pieces, and hopefully some big ones, as you say, like a part of the screen or some keys or something that's really obvious and doesn't even need to be, like a wait for the results. Just like, wow.
Well, I asked the students in my class, if we find a gadget with buttons on it, should we press a button?
No.
So indeed, half of them said immediately no, because it will affect all of us. Please don't do it. And the second half said, please do, because we are curious to see if it's, maybe it's ChatGPT 100, and we can ask it questions. And then a student said, given the split vote, what would you actually do, Professor Loeb? And I said, I will take it to a laboratory and examine it before engaging with it.
Yeah, and make sure if you push the button, make sure you're filming it, right? So that's what we all want to see.
The question is whether there will be anyone left to view that. But exactly. It reminds me that I also asked my class, suppose a spacecraft lands here and they invite you into it for a one-way trip. Would you go in? And they said, well, we would definitely go in as long as we can share the experience through social media with our friends. Like having access to Instagram and showing photos with the aliens or whatever. And I just couldn't understand it, because for me it's just the thrill of the experience. Why is reality not much more important than bragging about it? Like, it's not about showing off, it's just enjoying the moment, and if you climb the Everest, it would be to demonstrate that you can do it. If you meet aliens, it would be to understand them. It will not be to show off and brag about it to your friends.
Yeah. Yeah, absolutely. I completely agree. Unfortunately, I guess the age of social pressures and everything like that and social media has people thinking a bit differently. But yeah, I mean, I'm not sure I would get on board. I'd need a lot more context to make my decision.
Well, I will just mention that if you wanted to understand what's inside a black hole, you will have to enter through the event horizon of the black hole. And then there is no way the laws of physics would not allow you to transmit any information, to share an Instagram photo from your whereabouts inside the horizon, because even light cannot escape from that prison. So keep in mind that if you ever enter a black hole, there is no opportunity for social media again for you.
And depending on how far away from Earth you end up in this craft, it may be like a 50-year delay for your post to go live.
Oh yeah, so that's another another important point. Now, if you imagine traveling large distances, that's only possible if you approach the speed of light. So in fact, if you right here on Earth, we are attracted to the ground by 1g. That's the acceleration, gravitational acceleration on Earth. And we feel comfortable, right? Sitting on our chair, we are attached to it with an attractive acceleration of 1g. That's the surface gravity of the Earth. And it's different on Mars, it's different on the Moon, so if you imagine a spacecraft that is accelerating you at 1g, it would feel just like Earth. Okay, so we could sit there, we would feel just like we feel right now on a spacecraft that accelerates at 1g. According to Einstein's theory of relativity, it doesn't really matter whether you are immersed in if you are accelerated by gravity or if you are accelerated by a rocket. It's the same, it's the same. There is no difference between the two. And so if we were to be in a spacecraft that accelerates at 1g for a year, that spacecraft would reach the speed of light. So 1g times 1 year is roughly the speed of light, which is an interesting coincidence. And then that means that you will get very close to the speed of light after a year. And then if you continue to accelerate at 1g for maybe 2 decades, after that, you will approach very close to the speed of light. You can never exceed the speed of light, according to Einstein's relativity. And so time will be ticking slower in your frame on the spacecraft compared to friends that you leave behind. And while they may witness the journey as taking billions of years, for you it may be just 20 years if you keep doing that. And you could actually go across distances of billions of light years during that time. And when you come back to Earth, you will be just, let's say, 20 years older, but Earth itself would be billions of years older. And so there would be no life. In fact, Earth would probably by then be a desert because the sun will brighten. So you would find nothing from what you're familiar with. And if you were to continue the journey for 7.6 billion years, you would realize that the Earth doesn't exist anymore because it's engulfed by the sun and it spiraled into the center of the sun and evaporated. So now think about all the effort that people put in acquiring territories, like the Russians are losing their lives and fighting the Ukrainians for a piece of territory, and the same in the Middle East. All of this territory is of a rock that is a residue left over from the formation of the sun. Eventually, this rock will fall into the sun. And by the way, before it happens, the moon, which was part of the Earth and was just chipped off the Earth as a result of a collision with a Mars-sized object early on in the solar system history, that was an object called Theia, and that chipped off the moon. That moon, because of the engulfment by the envelope of the sun, 7.6 billion years from now, that moon will spiral towards the Earth and collide with the Earth. So the moon will be returned to Earth, and then the Earth will be falling towards the core of the sun and disappearing. And if you make your trip long enough, you will not find the Earth.
Yeah.
And it just shows how ridiculous are the ambitions we have right now. We invest $2.4 trillion in military budgets, engaging in conflicts, when the big picture is that nothing of what we fight for will be around in the long term. The only thing that, if we want longevity in the long term, we should explore interstellar space. And we should change our priorities instead of killing each other, which, by the way, makes no sense because each of us lives for less than a century. That's the typical lifespan. And then we shorten our lifespan by engaging in conflicts and dying in wars. And it's not an intelligent thing to do if you think about it from a big. And most of the stuff that you find in politics is not intelligent. It's all because our role models are politicians. They are not very smart, the politicians. If we find an interstellar partner that is more intelligent than we are, perhaps it will give us a better role model.
Yeah. Yeah, absolutely. It wouldn't be hard to get a better rrole model than today's politicians. I couldn't agree with you more.
Yeah, especially after watching the debate in the US. You realize that the future of humanity, is affected by.
Maybe you should run for president.
Well, the thing about politics is that it often appeals to
those that crave power, isn't it?
Yeah, well, it's not appealing to what we should aspire to be, but it's appealing to our ego or our sentiments towards other people. And very often people hate other groups, which again makes very little sense because they don't know the people the only people that you can hate are people that you don't know very well. And that's why soldiers have no problem pulling the trigger, because they don't know the enemy. They don't realize that the enemy has a family and they are very reasonable people. When you see them at a distance, you can pull the trigger and kill them without a problem. And in politics, very often the narrative is about things you don't know. And politicians take advantage of that. Politicians pretend that, to promote a narrative that people agree with, but it's a toxic narrative. And, just like eating fast food, when you eat it, it feels good. All the sugar feels good. You get addicted to it. And a lot of people like fast food. But in the long term, it's a health hazard. It shortens your lifespan, and it's not good for you. Now, if you were to run on a ticket saying fast food is not good for you, not many people would vote. Especially people who cannot afford anything other than fast food will not vote for you. So it's not easy to succeed politically by promoting the correct narrative, because people often retreat to something that is not good for them. And in a way, if you look at the history of humanity, it reflects those failures of us to understand that there is something bigger than that we can benefit from. And that's why $2.4 trillion are spent every year on military budgets. And I calculated that if we were to use those $2.4 trillion, out of which about $1 trillion is spent by the US alone, that's quite an amazing number. If you were to dedicate the same funds to exploration of space, you can send a CubeSat towards every star in the Milky Way galaxy within the next century. And
wow.
So one civilization that has a different priority than we have, instead of killing each other, they decide to explore space. They could have sent enough probes for us to find them, especially if these are self-replicating probes, probes equipped with artificial intelligence and and print 3D printers that can use raw materials to make copies of themselves. That's the trick that nature uses on Earth. If you think about the dandelion flower, it sends out seeds in the wind, and they go to fertile ground. There is no umbilical cord connecting those seeds to the flower. There is no transmission of radio signals from the seeds to the flower, nothing. The seeds just go out, and the hope is that at least a few of them will find fertile ground and use the DNA of the flower to reproduce what the flower is. And if you imagine repeating that or copying that technologically, these are self-replicating probes. Even a single civilization in our past history, just one civilization, over the past 10 billion years, could have filled the entire Milky Way galaxy with probes, because it takes less than 1 billion years for chemical rockets to cross the Milky Way from one side to the other. And whether there was such a civilization or not in our past has nothing to do with the Drake equation. So people often refer to the Drake equation as a way of assessing whether there might be a communicating civilization out there. And so you have to ask, which fraction of the stars have a planet like the Earth? Which fraction of those planets have a civilization? What's the lifespan of that civilization? I say, forget all of that. Even if there was just one out of the hundreds of billions that produce self-replicating probes, they could be next to us right now, because they had plenty of time, given that most stars formed before the sun. And if you ask yourself, why would they be close to us? The answer is that they need power. If you think about the human brain has, of the order of 100 billion neurons, and about 10,000 synapses connecting these neurons. And these are called parameters. There are also, you can make the analogy with neural networks that are used for artificial intelligence. They still have less connections, less parameters than the human brain, but they're getting close to it. And so these are systems like large language models, ChatGPT. And the human brain right now consumes about 20% of the power that is needed for the metabolism of the human body. So it's sort of the limit that you can imagine the brain developing to, because that's the maximum you can support by hunting or gathering resources from nature. And so the human brain, the human skull, developed up to the limit that is allowed by the power supply from the environment. So the human body could collect nutrients and resources, and that allowed the human brain to grow up to its current size. But it couldn't go more, because you would need more energy than you can get. So even if you eat all day, that's the maximum skull, brain capacity that you can have. 20% of the body, that sounds to me like a very reasonable fraction of the total. And so power limits growth of intelligence. And the same is true about AI. Right now, it's on an exponential growth with a doubling time of the order of 1.5 years or even less. But this exponential growth will eventually saturate once we will not have enough power to give it. So right now, ChatGPT is using about 1 gigawatt of electric power. And if it continues to grow exponentially, within 10 to 20 years, it will use more than the entire electric power available globally on Earth.
Oh, wow.
Okay, so indeed it can grow eventually to exceed the number of parameters in the human brain, but not by much, because eventually the power limit will limit it. And the same is true if you imagine alien intelligence. So, AI can stand for artificial intelligence, but it's also alien intelligence because, the AI systems that we developed, they are made of silicon, not flesh and blood, the way our brain is. And they are consuming a power of a gigawatt right now when the human brain is using just tens of watts to operate. And they are, transmitting signals at the speed of light compared to the much slower chemical, synaptic connections in the human brain. I mean, the speed of light traverses a distance of 150 kilometers during half a millisecond that it takes two synapses to connect with each other. And the human brain is 1,000,000 times smaller than 150 kilometers. So the hardware is very different, and that's why I think that AI systems are alien. They are not thinking like us. And of course, we can supervise them, we can train them so that they align with human intelligence the way we want them to be. But it may end up being like putting lipstick on a pig. It's a very different animal. And, you can put lipstick to try and beautify the pig, but it will still be a pig. And so AI systems will still be alien. And I think AI can stand also for alien intelligence in the context of the machines that we are developing. But there is also, that's just a taste of what meeting truly alien intelligence would be if we find a gadget from another civilization. And in that case, you ask yourself, okay, it will be limited by power again, just like the human brain or our own AI devices. And where can it be? Where can it charge its batteries? Where can it get the power? So the point is that the flux, the amount of energy per unit area, per unit time that is coming from a star declines inversely with distance squared as a function of distance from the star. And the amount of time that you spend at a constant speed crossing that distance is just proportional to distance. So that means the energy that you can harvest from a star would scale like 1 over distance, because the flux is 1 over distance squared, and the amount of time that you can dedicate is proportional to distance if you're just passing through. And so altogether, the amount of energy you can collect from a single star scales inversely with the distance. And that means that a probe like that, to charge its batteries, an interstellar probe would prefer to come close to a star. Just if it comes within the Earth-Sun separation, it will gain by a factor of 100,000 in energy that it can harvest, compared to if it were to stay in the midpoint between the sun and its nearest star. So it makes a lot of sense to come close to stars and get your energies, get your battery charged this way. So that you don't want to come too close to the star, because then the materials will melt. So at the Earth's separation from the sun, that's the habitable zone of the sun, and the temperature is for the 300 degrees Kelvin above absolute zero. If you were to come much closer, you would reach more than 1,000 degrees, and then materials melt. So the habitable zone is actually a very good place to visit, to charge batteries, to power your intelligence if you are an interstellar probe. And that's why we might have visitors at an abundance that is bigger than far out in interstellar space. And we should be open-minded. We should search for them. And obviously, that's what the Galileo Observatories are doing. And next year, in 2025, there would be a new observatory called the Rubin Observatory, operating in Chile. And it will survey the southern sky every 4 days. And it will employ a camera that with 3.2 billion pixels, 1,000 times more pixels than your cell phone, and could give us information about interstellar objects. And my hope is that among all the rocks and natural objects, we might find either with the Galileo Project observatories or with the Rubin Observatory, we might find every now and then some technological space trash from another civilization.
Yeah. Fascinating thoughts. And you've brought it back to the observatories and the telescopes, which is great because I want to ask you a few questions, a handful of questions about those. So I had one from Chris, who's one of my patrons. He said, Dr. Loeb, thank you for the continuous efforts on the topic of UAP. What is the current status regarding the data collection and analysis from the telescopes monitoring the sky? And I know you said at the start of our conversation that the Galileo Project has been analyzing 500,000 of the objects that you found so far, and none of them have been found to be anomalous so far. So I'll kind of merge his question with saying, how far through the 500,000 objects is the analysis? Have they all been analyzed, or where is that?
Right. So we just went through the data with human eyes, but we hope to do it with machine learning software, because AI can identify objects, as I mentioned, that are not obvious to the human eye. And the point is that we will either conclude that there is nothing really anomalous there in the data, in which case we can get a limit as to how many such objects exist. And I should say it may be just like real estate. There are three factors in real estate: location, location, location. And the same may be true in this context. And that means that we need to go to other locations, and perhaps Boston is not the best place. Also, we need to continue to do the search, because maybe at some point in time we will see something. But we could put limits during the observing window of, let's say, 6 months that we looked at the sky, as to, how to the fact that we don't have objects bigger than a certain size out to a certain volume around the observatory per unit time. So we put a limit, and that's the benefit of a search that is systematic. When people search for dark matter particles, they do exactly the same thing. They build an experiment that is aimed to detect a specific type of dark matter, and until now, over the past 40 years or so, they searched and searched and didn't find anything. So what can they do? How do they justify getting funded? It's by putting limits and saying we have a limit on the cross-section for the interaction of this particle with the experimental setup, with the material. And so we can put limits on objects of a given size in the Boston area. But as I tell my research team, if we find one that looks anomalous, that would be a subject for a full paper just about that one.
Yeah.
And so it's really looking for outliers. And something might pop up from the AI system that we use, next week. I cannot tell at this point, because we didn't go through the entire data with the AI. We just looked at it with human eyes. But also the other possibility is that when we get the data of next month, something would show up.
Yeah.
But at the same time, in the coming year, we will also collect data in Colorado and Pennsylvania. And so, I would say we will have millions of examples. And that's better than any other data set on this subject before.
Yeah,
of course, there is amateur data, but very often it's not calibrated. You can't trust it. It's difficult to make a statement.
So far, all of those 500,000 objects were from the Boston Observatory, the one at Harvard, or
Yes.
Okay.
Because the one in Colorado, we just started assembling it about a month ago, and the one in Pennsylvania resulted from a grant that we received of nearly $600,000 from the Richard King Mellon Foundation, and the condition there was to build an observatory in Pennsylvania. So we are now purchasing the components, and we hope to put them together within a few months and start getting data there as well.
Yeah. Do you still hope to, I think you did tell me this in the past, that you hope to put one in Catalina Island. Is that still
we hope to do that. In fact, the observatory in Colorado will potentially be portable. We could put all the components on a truck and bring it to another location. And indeed, the Catalina Island is a very interesting target for that destination.
Yeah. Okay. Awesome. And when do you anticipate that the machine learning, that the AI, whatever program that's going to analyze this data, when will it have gone through the initial data set, the initial 500,000 objects?
This summer, by the end of this summer. That's my hope.
Okay. Awesome. And you said, nothing anomalous has been seen by human eye, but you said that might be able to pick up things that were not visible to human eye or that were missed by human eye or whatever.
Exactly.
Okay. Awesome. Well, we look forward to kind of continuing updates on all of that. Do you have like an end date in mind in terms of the telescopes, or is it very much an open-ended thing? And
it's only limited by funding, and we are at the beginning of the journey. I hope that we can continue, that we will have enough funding to continue for the next 5 years. And of course, if anyone wants to support it, if anyone wants an observatory in their home state, it's about $500,000 for any copy of the observatory. We know how to make it, and they can just approach me if they have interest.
Yeah, I'm surprised Bob Bigelow hasn't asked to have something set up yet. Has he not reached out to?
His granddaughter reached out to me and said that she's inspired by my work and that she will reach out to her grandfather. But it may well be that at this late phase in his life, he is interested in other things.
Yeah, well, I know he has multiple interests, but I think that still seems like it would be an easy one for somebody with as much money sitting around as him. Last time we spoke, you gave a kind of very revealing but non-answer, if you see what I'm saying, like facial expressions, body language, that kind of thing, about the question whether you or the Galileo Project had seen or detected a UAP. We've established that the Galileo Project hasn't detected anything anomalous so far, but have you seen anything? And if not, can you kind of reveal what it was last time that made you, if you recall, that made you kind of give me this kind of interesting answer that even some commenters picked up on, I think, where it was kind of like maybe talk to me again in the future, and nothing. It was interesting.
Yeah, I mean, there were some instances in the past where we thought that we have something anomalous, but turned out not to be substantiated. But the most interesting development from the last time we spoke was the testimony under oath by David Grusch to the US Congress, arguing that there is a program for retrieval and reverse engineering of materials from crash sites that indicates extraterrestrial origin. And I spoke with David for an hour over Zoom and asked him for any specific evidence, but he said that he is unable to provide it to me because of the legal implications. And apparently he doesn't want to become the Snowden of UAP. To get into legal trouble by revealing everything he knows publicly. So at the same time, I attended an event on Capitol Hill just last month and met Sean Kirkpatrick as I left this event. It was a lecture that I gave publicly there and in Washington, D.C. And he was the head of the All-Domain Anomaly Resolution Office that was established after the Director of National Intelligence delivered the 3 reports to the U.S. Congress by now. And I asked him whether he saw anything interesting that is extraterrestrial potentially. And he said no. And I asked him, are you sure that you had access to everything? And he said yes. And so then the question is who to believe. And obviously, the US government has some interest in counterintelligence, basically introducing false narratives so that it confuses other nations, adversarial nations, as to the capabilities that the US has and knowledge that the US has. So the question is, which side subscribes to this counterintelligence effort? Is it the side that says we don't have anything? Or is it the side that says, yes, there is something going on? And I cannot judge from the outside without seeing the evidence. And it's possible we would never see it because it doesn't exist. But as of now, I'm completely agnostic. I'm intrigued by the reports from the Director of National Intelligence, and I actually met Avril Haines in the green room of the Washington National Cathedral shortly, about 5 months after her first report. And she has a bachelor's degree from the University of Chicago in physics, and we speak the same language. And I approached her and I said, Avril, you just delivered the report. What do you make of these objects? What's your gut feeling? And she said, I don't know. And I believe her. I think it's just that the data is not good enough. It's quite remarkable that those officials are willing to admit that they see things they don't understand, because that means that they are not fully doing their job. I mean, if it's adversarial nations that are engaged in espionage, this is what they're getting paid for, to find those objects and identify them. But and we know about the Chinese spy balloon that was shut down, and so I'm completely open-minded and agnostic. And I had a visit by a former high-level official from Lockeed Martin, and he said that it's not necessarily wrong what David Grusch was talking about. So it's really a confusing situation, and it's difficult for me to make sense of it, because there are conflicting views, both expressed by different people from within government that used to be within government, so they're now not, and also by the secrecy that is associated with classified information. And my hope was that the Schumer amendment to the defense bill last year would establish a board that would advise the US president as to which information to release to the public or to scientists. And that amendment was gutted. And now we are in an election year, so there is very little prospect for it being revived. So the only hope that maybe if such a board will be established within the defense bill, it would happen in 2025. And for now, we are still in the dark. And, you can wait for the government to tell you what lies outside the solar system. That's not really their day job. And also, the government is not a scientific organization. And my view is that, we can take this knowledge in our hands, and the sky is not classified, the oceans are not classified, and we can try and figure it out ourselves. That's what I'm trying to do, because that's my day job, to find what's outside the solar system.
Yeah. As always, there's lots of things I want to pick up on and ask you about. One thing with Kirkpatrick, you said, was he sure he had access to everything? And yes. I guess it makes me think of something you said earlier about the unknown unknowns. And it's like the blindingly obvious thing of would he know if he had access to everything? And how is he so confident that he is able to say, oh yeah, I had access to everything, rather than because how would he know realistically? If there was something that was above top secret, whatever, in a SAP, a special access program, you don't know what you haven't got access to, if you see what I mean, right?
Yeah. That's as long as government operates in an uncoordinated way, where only a small number of people are aware of the full scope. And of course, the president of the United States is supposed to know everything. And we did hear from some presidents that hinted that there are things we don't understand, including former President Obama.
Yeah.
So obviously, if I was the president, I would know more, but I'm not. And I'm not signed on any non-disclosure agreement. What you hear from me is what I know. And unfortunately, there is not enough information for us to judge by and decide which side is more credible. And there are some believers, people who say, we know the answer. It's obvious. It's this or that, but it's not based on evidence. And it's a risky thing. People who believe in something just because of conviction you find a lot of those in religions. That there are lots of people who believe in things. I mean, as a matter of just belief. But that's not the way that scientific knowledge is advanced by. What you need is evidence. You can't rely on people. People are not reliable detectors. And by the way, it's not my opinion. It's the opinion of FIFA, the Soccer World Organization, because if you watch the matches in the European soccer contest, you would realize that decisions are often made, and especially if they're controversial, on whether there was a goal or not, they're made by looking back at the video recording by instruments. And the referee decides if there was a goal or if there was a hand, or just by looking at the data, not going around and asking the players what they think. Yeah. And if you just go and ask around people in government what they think, they will tell you. If you ask like Sean Kilpatrick or David Grusch, you'll get conflicting reports. Now, this is not unheard of, because when there is a car accident, different people that were involved in the same event give you conflicting reports. And my conclusion is, instead of going around and saying, I believe that person, not that person, which many people do on social media, instead of that, I say, okay, is there any data on the event? I want to look at the data. And if nobody recorded anything, I say, well, that's not good enough. I don't know who to believe.
Yeah, it's a really tricky one. Obviously, you've spent time interfacing with both of them, so I kind of, part of me wants to be like, come on, Avi, which one did you smell was like kind of BSing, and which one came across as more honest? But I know you probably don't want to go down that road.
Well, that's a question for a psychologist. You see, and you're asking the wrong person, because the one thing about me is that I'm relatively naive and I'm not manipulative. That's the reason I was chair of the astronomy department at Harvard for 9 years. I was the longest serving chair for 3 terms. When I started, my wife said you would not survive a day, because I'm not manipulating people. What you see is what you get when I speak with people. And she said, in politics, you can't survive this way. You have to give people a story that is not always true in order to survive in politics. And somehow I not only survived, but continued for 3 terms as chair of the astronomy department, 9 years. And you ask why? It's because I didn't manipulate people, and they believed me. And they never heard the sides of a story that was fabricated, or they always knew where I'm standing. And I always tried to help. And so, that's my strength in a way that made me be in a leadership position for a very long time. But it's also my weakness, because when I speak with Sean Kilpatrick and I speak with David Grusch, since I'm not manipulative myself, I cannot judge who is manipulating me, because they are a different breed. It's a different animal. Those people who manipulate others, I cannot understand them. I cannot see why they would try and fool people, but they do. I mean, there are lots of people who fool other people. We see them every day. And so for me to decide which among these two, I mean, it's possible that both of them are sincere and they were just misinformed. So for example, in the case of David Grusch, he heard from 40 eyewitnesses, people who told him about what he was talking about. Maybe some of them tried to fool him. In the case of Sean Kilpatrick, perhaps he didn't have access to some information that would have changed his opinion, as you said. And so in that case, both of them might be sincere, but the reasons for why they're not telling the truth is because they are unaware of the truth.
Yeah. Although I do think Grusch didn't he more recently maybe allude to the fact that he may have some kind of first-hand knowledge, but obviously he hasn't. I don't think he's shared that with us yet.
So that's the key. You see, saying you have the knowledge is not sufficient. Now, it's true, there are people, and I heard it not just from him, who say they heard from some people within government who looked at real evidence, and it's really peculiar. What they have is really peculiar. But once again, if I don't see that evidence, people can find something peculiar that ends up being explainable with a very mundane explanation. So it's really, the devil is in the details. You really need to see the data to decide. I mean, it's just like telling the referee, the data exists that will indicate whether there was a goal or not. but we can't share it with you. So what will the referee decide based on that? Nothing. I mean, the fact that the data exists, but other people are looking at it, is meaningless.
Yeah, you need to see it. So just tell me a little bit more about the time that former Lockheed Martin official visited your home, because obviously that's fascinating. I think you wrote about it in your Medium. You mentioned it just now. You've said that you asked him about Grusch's testimony. You asked him, is it conceivable that Lockheed Martin has materials related to those programs? And as you said, he said, I would not say that it is wrong. So, like, can you tell me more about that interaction? Anything that you can share?
That was all. And he didn't give more details. And that was December 2023.
Mm-hmm. Did that impact your thoughts on the whole thing, at least in the sense of making you remain more open-minded to Grusch's testimony under oath?
I mean, obviously, you see one side and you see the other side, and there might be more members of one choir versus the other choir. Mm-hmm. And that, again, doesn't necessarily say that the most popular choir is the correct one.
Yeah.
So I really want to see the evidence. That it's key. I mean, you will, on social media, on X, for example, you will find a lot of people who are vocal. They know the answer, but that's not the way to decide. The way to decide is for all of us to see indisputable evidence that you can't interpret as being human-made.
Mm-hmm. And have you heard similar things from anybody else, like as that official that came to you and said, I wouldn't say it's wrong? Have you had that has that been a recurring theme for you in discussions with people?
The one other thing is, as an example, I went to give a public lecture at CERN, mm-hmm. In Switzerland, Geneva. And there was a special dinner with VIPs there, about a dozen people with a high net worth.
Yeah.
And around the dinner table, two of them talked about, we asked the question, did anyone have an experience? By the way, myself, personally, I never had an experience. I work on this subject because of my curiosity. I want to figure it out because, other people are saying there might be something out there. And I know about the astronomical data that indicates that interstellar objects appear to be unusual. Oumuamua and the meteor and so forth. So anyway, two people around the table were saying that they had experienced about a decade ago or 2 decades ago of some very unusual object that showed up where they were. And we're not talking about a small object that was passing briefly. It's like a big object. And in one case, they saw fighter jets chasing it. Oh, wow. And it's not just a single person, but his friend was there and so forth. And that was just that dinner. So, some people did see an unusual thing. Now the question is, was that human-made or not? Mm-hmm. And the claim by those people is that it couldn't have been because it was moving faster. It was like a big thing and moving faster than the jets, and just couldn't be. It was moving in ways that could not be explained by the technologies of the day. Mm. And the problem is, if such events take place, once per several decades or once per decade, there wouldn't be perhaps many witnesses, and we wouldn't know if some government started operating a new technology that nobody is aware of. So it's really, we really need the data that we can analyze on these events that would be conclusive. And the quality of the available data right now publicly is not good enough for us to do that.
Yeah.
I mean, in my opinion, if someone has that, please share it with everyone. Let's see if it can pass the scrutiny of scientific investigation. I mean, we really need very high quality data that illustrates beyond any doubt that we're looking at something that is not human made.
Yeah, absolutely. Quick questions about that dinner with CERN then. So that person that saw the object being chased by jets, you said 2 people saw the same event there, and they both were there and confirmed that? That is interesting.
Yeah, and it was discussed at the time, but again, people just ignore it because if it's just, they didn't take any data of what they saw.
Mm-hmm. Mm-hmm. And how many people were at the dinner, and what was the kind of vibe when that topic came up? Was it kind of like, was there that stigma, or was it very much more open?
No, I mean, those people in particular argue that the stigma should be lifted because we should be open-minded, and there are very unusual events that take place, and we should look for them. And so the overall vibe was positive.
Hmm.
Uh, and I think if you poll the public, you would find that there are more people that believe in extraterrestrial technological civilizations, intelligent civilizations, than the fraction of the American public that believes in the biblical God.
Hmm.
And that poll was made actually a couple of years ago. Now, to me, it means the public is very open-minded. So when scientists are saying, we don't want to fund such research because it's too risky and we will waste taxpayers' money if we were to fund it, I say, ask the taxpayers if they are willing to spend the money
Yeah.
on this risky proposition. If the taxpayers really are interested in this question more than they are in the nature of dark matter, then we should invest at least as much as we do in studying the nature of dark matter. And that has been billions of dollars over the past few decades. Okay.
Yeah.
And the amount of money dedicated to scientific research on unidentified anomalous phenomena is in the millions. It's
Yeah.
not in the billions. And my point is, why shouldn't we diversify the portfolio of scientific research to address questions that are of great interest to society? Why is that banned by the scientific establishment? It shouldn't be.
Sounds a little bit too much like democracy, doesn't it? Asking the people what they want to study, because obviously people would be way more interested in studying this kind of phenomena and the work
Yeah,
you're
I mean,
doing than yeah,
it's not just the will of the people. It's more to do with the fact that we have the technology, we have the instruments that can
yeah,
allow us to answer.
yeah,
So, like, those UAP that the government talks about, there are real objects in the sky, and the fundamental question is whether they're human-made or natural. And that can be addressed by investing. If I had $1 billion, I would find the answer for you within a year or two, for sure.
yeah,
It's not complicated. This is doable with existing instrumentation, existing technology. And just think about it. We invested billions of dollars in the search for dark matter. What impact would it have if the dark matter was weakly interacting massive particles? Like, okay, the Nobel Prize will be awarded to those who find it, and we will move on. But if we find that 1 out of a million objects in the sky happens to be of extraterrestrial technological origin, the impact on the future of humanity would be huge. First, it will change our perspective about our existence in the universe. And more importantly, it would allow us to learn about technologies that we don't possess.
yeah,
When Steven Weinberg, the Nobel laureate, argued that the more that was in his book, the first 3 minutes, the more the more the universe is comprehensible to us, the more pointless it looks, it seems. He was expressing the sentiment shared by many of my colleagues that there is no point to the universe. You just look at it, and and things happen in it. But we know from our private life that finding a partner changes the meaning for our existence. And so finding a neighbor in our cosmic environment would change everything for us. The universe would not be pointless anymore. We would not feel lonely. And just insisting that we should study particles that are lifeless and stars that are lifeless, and that having a partner out there is an extraordinary claim. I think that's very arrogant and pretentious, because I don't think of us as exceptional, as privileged. I think there are hundreds of billions of Earth-Sun systems in the Milky Way galaxy alone. And, we are not that special. Life probably is thriving out there, and things like us existed in the past, and we just need to search for them. And why is that so extraordinary in the minds of some people? It's because they want to believe that we are unique and special. And that includes Elon Musk, who argued, we should go to Mars because we may be alone. That in fact, the 6,000 Starlink satellites, communication satellites, never collided with a UAP. And I calculated that if you have an object roughly a meter in size at the same altitude as Musk's communication satellites, 550 kilometers above the Earth, it would take 1,000 years before it will collide with one of these satellites, even if you put it at the right altitude. And why would it be at that altitude? And the point is, it's the same as arguing that we've never seen the Higgs boson with these satellites. They never collided with the Higgs, or at least we didn't see evidence for the Higgs boson in their data. And therefore, we shouldn't search for the Higgs boson. Well, we had to invest $10 billion in the Large Hadron Collider at CERN to find the Higgs boson. You need to develop instruments that are tailored to the knowledge that you're trying to find, so you can't just say, I have satellites for communication and they don't tell me anything about UAP, because they were not designed to search for UAPs. They are not really optimized for any, for them to collide with a UAP would require very special circumstances. And so, new knowledge doesn't fall into our lap. We can't do other things and by chance realize that we discovered new knowledge, because nowadays in science, you really have to invest a lot of money and effort. That's what I usually say, that extraordinary evidence requires extraordinary funding. And so, right now, what I'm doing is limited by funding. If I had $1 billion, I would make much more advances in this context.
Yeah, absolutely. And what you said about Elon and they haven't crashed into any of my 6,000 satellites. I mean, yeah, again, like there's lots of potential reasons for that, which you outlined, but also if it is something that's intelligently controlled, it's like saying I put a cone in the middle of the road and no cars hit it, so there are no cars there. That's it's not necessarily the best logic there.
No, that's a good point. And so there are two types of objects. There is space trash, things that do not function, like Voyager will become once it exits the solar system in 10,000 years. And these would collect just like plastics in the oceans. And, they might collide with Earth and appear as unusual meteors, like this meteor in the Pacific Ocean. And then there are functional devices. And those could be intelligent, as you point out, and they would not behave as randomly oriented objects. And so we really need to stop having an opinion on this subject. A lot of people decide ahead of time, they know the answer. That includes both believers and skeptics. They have an opinion to start with. And it sounds like politics, because you have this polarization in politics. The extremes dominate the agenda because they fuel each other. The believers make statements that sound completely crazy to the skeptics and vice versa.
Essentially, they're both believers, right? Just different flavors of believers.
Well, that's an interesting point, because there were a number of congressmen that made anti-gay statements during their career. And then when they left office, they confessed that they are gay. And so what does that teach you? That some of those skeptics might be deep down believers. And so, and they just play the game to pretend that, it's called virtue signaling. They're signaling to their constituency, but in fact, they believe in something else. And that's why they care so much about the subject, after all, because if they really were skeptics, they would not even pay attention to this. So anyway, you have on the one side the camp of skeptics and the other side believers, and they both attack me personally. I can give you examples, but just doing what sounds like common sense, taking the middle road and trying to collect evidence. First of all, it requires a lot of work. But secondly, it's not a road that is populated. And so, for example, when someone asked me on a podcast, they said, well, maybe if we train AI, then it would be it will do the right thing and go in the middle of the road. And I said, very unlikely, because if you train it on human content, and most of the data is in the two camps of believers and skeptics, there is no data to train it on in the middle of the road, and therefore it will be one of those, and it will adopt an extreme position, which is very bad. So actually, the only way to resolve this situation is to have a larger number of reasonable people that use common sense to guide them. And by the way, this is not just true in politics, as you can imagine. I mean, watching the last debate in the US, it's also true in the context of science, which is surprising, because you would think, we learned a lot from the history of science. We realized that sometimes ideas that are not within the beaten path prevail, and we should allow them. We should be open-minded. And the answer is no. The way science is practiced is very often controlled by people who want to maintain past knowledge and resist new knowledge, because they got their reputation, their stature out of past knowledge. So just to give an example, if they are experts on rocks that fall from the sky, meteors, they would insist that anything you find falling from the sky must be a rock. And that's by itself very paradoxical, because before 1803, nobody believed that rocks can fall from the sky until there was a meteor shower in Liège, France, and convinced everyone that indeed rocks can fall from the sky. And the same was true about rocks found in the periphery of Africa versus rocks found in the periphery of the Americas. Alfred Wegener argued back in 1910 that in fact it's like a jigsaw puzzle. You can fit the different continents, and he argued that perhaps they were part of a supercontinent if you go back hundreds of millions of years, and people resisted that idea. He died in the 1930s, and his theory was completely rejected. And then in the 1950s, evidence was found that the rocks indeed match, the vegetation matches, and indeed all these continents, Americas, Asia, Europe, Africa, Antarctica, and Australia were all connected in a you could have walked from Europe to the Americas. You didn't have to take a flight. You could have walked from one continent to the other if you were to live 250 million years ago. And then plate tectonics explained it. So you find those historical examples, even about rocks, that convince us that we should be open-minded to new ideas. And you would think that rocks are very down-to-earth kind of a subject. But now I get scrutinized for arguing that there was an object that came from interstellar space, and moreover, that the composition is different from a rock from the solar system. And so that leads some experts on rocks to argue that the data must be wrong. I mean, what could be more arrogant than saying the US government data is wrong, the velocity was half of what it was reported to be of this meteor, because otherwise I cannot fit it with a solar system rock, a model for that. I mean, the whole point about science is that when a model doesn't fit the data, you should consider alternatives. But these people are not willing to do that. They're attacking their research that I'm doing by saying maybe you found coal ash, maybe the meteor was a truck, all kinds of very unreasonable statements. And it's really unfortunate. That's from the skeptics' side. And then from the believer side, if some astronomers in Ukraine are seeing dark objects and they claim that they are at a distance of 10 kilometers and they move at a speed of 15 kilometers per second above the escape speed from Earth, then those believers say, well, these are objects violating the laws of physics and they are extraterrestrial in origin. And I say, well, wait a minute, did they measure the distance in a reliable fashion? And the answer is no, they just had one station looking and estimating distance based on some unreliable method. And I say, well, in that case, if the distance is 10 times closer, then these objects were moving at a speed of 1.5 kilometers per second. And then there would be artillery shells, or if there are even another factor of 10 closer, there could be bullets. And in Ukraine, during the war, you could have such things. So why would you argue for new physics? I mean, just realize that when you claim new physics, you should get the Nobel Prize. So the only way to argue for new physics is if you have data that you cannot explain beyond any reasonable doubt otherwise. Physicists are working on that for decades. They build very exquisite experiments to search for new physics. So we cannot just say, oh, the data is crappy and therefore it could be new physics. That is not a right approach. You need to collect exceptional data that you cannot interpret in any other way, that will tell you the distance, for example, through triangulation with very small error bars. And that was not done in the Ukrainian report. And so the believers get upset. They say, why would you doubt what they say? Well, the answer is because the data is not good enough. That's all. I would doubt it if the data is not good enough.
Yeah, absolutely. So you take shots from both sides, basically, which is not an easy road to walk, but we appreciate you walking it. And as you kind of outlined there, science can be a battle to kind of progress things and for people to realize the progression, the trajectory. Anyway, I've got a couple of questions here from Robert in Singapore. He's one of my patrons. How do you suggest listeners outside the US approach governments and or universities to start research work that is complementary to your own? And do you have any thoughts specific to Singapore?
Well, that's a very interesting question. So one possibility is for me to collaborate with someone over there and help them get into the grooves of doing such research, because by now we have experience of several years. So I would be happy to speak with that person. They can just email me and establish a time for a meeting. And then, of course, the key would be to find scientists at the location of their interest that are excited about the prospects of studying it. And in principle, one can build observatories all over the world for such things.
Mm-hmm. Awesome. Well, I tell you what I'll do as well. I'll send you an email later on or tomorrow or something. I'll copy him in, and you guys can connect from there. He can kind of follow it up with you from there.
Okay. Yeah, so by the way, just to explain, science and knowledge acquired by science should be shared by everyone. I call it an infinite sum game. Very often in politics, you're involved in zero-sum games. If one side gets territory, the other one loses it. That's a zero-sum game. But in science, gaining new knowledge is of benefit to everyone. And therefore, it's an international endeavor. Collaboration is always encouraged. And the more people are looking at the sky, the better we are, because we will figure out if there is anything unusual out there.
Yeah, 100%. Another question from Robert here. Research grant applications usually require a discussion of the commercialization opportunities for the research being performed. What do you see as the opportunities for your work?
Right. So, for example, studying interstellar objects, if we end up finding that these are rocks from another star, that is very interesting by itself, because it would be, for example, the first time that humans put their hands on objects that are big, that came from outside the solar system. In the past, we only studied dust particles, tiny micron-sized particles. But in the case of the meteor, if we indeed found the materials from it, it was the first time that material from a big object from outside the solar system was studied. And that is significant because we learn about environments that are far away by studying materials from them. And as I mentioned before, if during the process of the formation of a planetary system near the most common stars, dwarf stars, you happen to eject rocks at a very high speed, 60 kilometers per second, and a very unusual composition, like the Belau composition that we found, That's new knowledge. That was not known before. And that's exciting. Just think about finding rocks in your backyard of your home that came from the neighbor's yard. It tells you something about your neighbor's yard. If you happen to find a tennis ball, it will tell you that the neighbor plays tennis. And that would be the equivalent of finding some artificially made object. But even if you don't, just finding objects is a very different way of doing astronomy. In the past, astronomy was practiced by looking for light, collecting light with telescopes. Here we're dealing with objects. It's a very different study because objects carry much more information on them that you cannot necessarily observe at a distance.
Mm. What are your latest thoughts? I know you hate to speculate, but what are your latest thoughts on UAP and the UFO phenomenon in general? Do you have any kind of, how has that updated or progressed since the last time we spoke? What are your latest thoughts on that? Is there still, do you think there is a there, and all of this kind of thing? Like, where's your head at with this?
Well, I think it's intriguing, and I think we should keep searching, and the best way is to do it systematically, the way I'm promoting with the Galileo Project. And I think we should do it for a decade with a budget that is at least 10 times bigger than right now. And or if we get a budget that is 100 times bigger, we can solve the mystery even earlier, within a few years. So it's all a question of funding. And I do think that this must be done in order for us to put to rest all the speculations. And given that the public is so interested and that the government talks about things they cannot understand, let's just figure it out. Why is that so difficult? I mean, the amount of resources I'm talking about is at a level of tens to hundreds of millions of dollars. As I said before, we invested much bigger sums, billions of dollars, in the search for dark matter, in the search for supersymmetry in the Large Hadron Collider. We haven't found those. Nobody says it was wasted money and science should not be funded after that. And all I'm saying is that invest at least 1/10 of that money in a search for something that the public and the government cares about.
I got another question here from a patron. What are your thoughts on the idea that an element of government could be building a UFO threat narrative to increase funding to the military-industrial complex and allow for emergency powers legislation?
Yeah, so it's possible that it's a fabricated story, but not for that reason. My guess is if it's fabricated, it's in order to introduce a narrative to the public that, there are things that we don't understand that may have come from another star that could have crashed on Earth. And the reason they would do that is because if the government or the military develops technologies that are well beyond what we currently know about, and some citizen happens to see them, they would say, oh, it's a UFO, it's a UAP. They would not necessarily say it's a new technology that the US government is developing. So that's good for government, because the adversarial nations will not be sure what it represents, because there will be this narrative of UAP, UFOs that the public thinks about, and then nobody would believe it anyway, and then it will go away. So it's a way of sort of raising enough dust to claim that we don't see anything. And so that could be a good reason to do this. But we don't know whether that's the reality or not.
I have a couple of questions from Liam on YouTube. He regularly comments on these videos. I know that the topic at the center of the question is maybe not something that you're particularly familiar with or have looked into, but I thought I'd ask it anyway. Is the abduction phenomenon a major obstacle to beginning a disclosure process? And are there any other disquieting behaviors which would be problematic to discuss openly?
Yeah, so the fundamental question in this context is whether abductions take place. So the problem I have is that this is based on eyewitness testimonies. I mean, if someone were to say, I was abducted and here is material evidence that I collected from the spacecraft that abducted me, that's a different matter. But if they just talk about experiences they had while abduction took place, it could have been a dream. Now, of course, psychologists or people who specialize in spirituality would argue that's very interesting, and let's try and cross-correlate the stories of people who were abducted. And by the way, those people know about each other. It's not as if each of them is completely different and separate. And so if their stories match, it could be that they simply know about each other. And they just repeat the same story and try to, and maybe they had a very personal and very unusual experience. And, people have experiences that are unusual. People even take drugs to feel an unusual experience. So if someone took, a very unusual drug and comes back and says, I went into a portal that told me, allowed me to explore extra dimensions, would that be regarded as evidence for extra dimensions so that this person will get the Nobel Prize because physicists are talking about extra dimensions? The answer is no, because there is no material evidence that this person can use to demonstrate that there are extra dimensions. There are experiments that people are trying to conduct that will explore extra dimensions, but none was conclusive. At the moment, we only have limits, okay? And so a spiritual experience could be very revealing to the individual, but it doesn't hold water in the court of science. Mm-hmm. And of course, psychologists can study that. John Mack at Harvard did that. And I have no issue with that because it may well be a psychological condition that is interesting by itself. But for it to be evidence for something real is a different matter. Because as I said, when different people are involved in the same car accident, they report very different things. And that shows you the human mind can introduce narratives that are not real, because it can't be true that, all of them tell the truth if they all participated in the same event. The car crashed, something happened to the car. If we were to film it and record it, we would know exactly what happened. So you can't believe both sides of the story. One of them, or maybe even both, are not realistic. And that's the approach that FIFA takes when deciding about a goal. And so that's the approach that science takes. Now, in the courtroom, you can have eyewitness testimonies that put people in jail. But we know of cases of people that didn't commit a crime that were put in jail. And that's really the danger of going that path.
Yeah. I assume somebody as open-minded as yourself, though, doesn't rule out the possibility of some kind of physical
in
abduction.
fact, I'm intrigued by those testimonies. I don't dismiss them. I don't ignore them. And I just say we need better evidence. That's all I'm saying.
Yeah, absolutely. Because it does seem, from a kind of base level point of view, when you just think about it, in the sense that, okay, if there is a technologically advanced species visiting us here, interacting with our planet, it's certainly a possibility that they would want to abduct is a very provocative word, but take certain animals and humans to, not that we're not animals, we're all animals, but to study and to learn more about and that kind of thing.
No, right? Definitely that's possible, and that has been the subject of science fiction stories, right? So it means that it's possible, but of course we need material evidence. I mean, that is the key.
Yeah. Some scientists from Cambridge University, including, I'm probably going to pronounce his name horribly, and I apologize to him if he hears this ever, Niku Madhusudan, think that they may have recently discovered life on an exoplanet. Have you come across this story? And I'm sure you have. And if it's proven to be true beyond a reasonable doubt, how would that impact the UAP discussion? How would that impact your work? And how would that change the world as we know it?
Right. Well, that particular report was about an exoplanet, a planet that transits the face of the star. So in other words, its orbit is aligned with our line of sight so that it passes in front of the star every orbit. And as a result, it was possible to use the Webb telescope to search for the composition of the atmosphere of that planet. And so the Webb telescope provided a spectrum, and in the spectrum, you can look for the fingerprints of various molecules, one of which was dimethyl sulfide, a molecule that is produced by life in the ocean, in our oceans on Earth. And the problem is that this fingerprint in the spectrum, the spectral fingerprint, was not statistically significant. And in fact, it could be related, as some other scientists argued, it could be related to a different molecule that is common. And so there are two issues with that report. One, that the feature itself that was claimed to be dimethyl sulfide might not be real, because the statistical significance of that feature was small, and they are trying to get better data from the Webb telescope to establish it. Second, that it was potentially from a completely different origin that has nothing to do with life, like methane, for example. And then there is the whole question of, okay, suppose you found evidence for such a molecule, does it necessarily imply that life exists? I mean, and there are people who would say, well, you can make this molecule in some other way that is geological or chemical, that avoids the need for life. So it will remain, even if you were to substantiate this molecule and differentiate it from anything else, there remains the question of whether you can get it from anything natural that is not associated with life. And that ambiguity will remain until we find industrial pollution in the spectra of planets. Yeah. And industrial pollution involves molecules that nature cannot produce. They're just too complex. And that our industries, for example, these are CFCs, for example, and I wrote a paper about it in 2015, about a decade ago. And, our industries have refrigerating systems that make those molecules. Nature doesn't do that. And if we find industrial pollution, of course, that would be quite indicative of life, and moreover, of a technological life on that planet. But, that is not considered a target in the plans for the next observatory by the astronomical community. The priority is given to biosignatures, these molecular fingerprints that may indicate the existence of microbes. And I just think that we should hedge our bets, not only search for primitive life, microbes, but also search for technological life on those exoplanets. Unfortunately, my view is not popular enough for it to appear in the blueprint of the future telescopes that are being funded, or at least planned. And you ask yourself why, and that is because, once again, we should not waste taxpayers' money on risky agendas. But the question of whether we would find first primitive life or intelligent life is unsettled, because even though we know that the microbes existed on Earth as soon as it cooled 4 billion years ago, they may be indeed much more abundant in around other stars than intelligent life. The point is that they produce very subtle signatures that are difficult to pick up, and even if you pick them up, you're never confident. If you just see the molecular fingerprints, you don't know if there was a natural process that made those molecules that has nothing to do with life. Whereas if you find a technological signature, that could be beyond any reasonable doubt evidence for life. So I would argue that we should hedge our bets. We should split the funding between the search for microbes, which might be very abundant but have very subtle signatures, and the search for technological signatures that may be rarer but much more conclusive when we find them. And that would be my recommendation as to how to split the funds. But it's not, you won't find it in the plans for the next decade or two in astronomy.
Yeah. Yeah, which, as you say, is disappointing because it would be great to have something so conclusive as that. And I'm guessing setting up a telescope like that's a little bit beyond the funding that you have access to at the moment.
Right.
Yeah, yeah. So you mentioned earlier a Netflix documentary is being made about your research and all of that kind of thing. Can you tell me a little bit more about that? Like when that started filming, how that came about, when you said it's going to be released late 2025, did you say?
Yes.
Yeah.
Well, it started a couple of years ago, and they followed me both in my research and my expedition to the Pacific Ocean. That they have some amazing footage,
Mm-hmm.
and it should be quite exciting. The other thing that is about to come out in the middle of July is a TED Talk that I gave in Vancouver. It should appear on July 15th at 11 a.m. Eastern Time everywhere. And when I gave this talk, I actually was advised by the TED, I mean, that was the annual TED conference, and the organizers advised us to practice, practice, practice. And I just didn't have time. And, I'm not an actor, so I have difficulty memorizing narratives. And so I just didn't practice at all. And then the night before, because of the time difference between Vancouver and Boston, I woke up actually around midnight, and I had nothing better to do than prepare my talk. So I wrote an essay about it on medium.com, and then I had all the narrative laid out for me and immediately gave the talk afterwards without any practice, just speaking from my heart. And there was a standing ovation in the auditorium and in simulcast, which is quite unusual. So my hope is that once it comes public, it will catch some fire in the general public, because the TED conference organization gets more than 22 million followers. And so that's also a very interesting development. And then there is also a play that was written about my research. It's currently being considered by a theater. And that was written by an accomplished playwright, Josh Rovech from Los Angeles, that contacted me one morning and in an email in March 2023, and he said the title of the email was Avi Loeb on Broadway, and I thought it's one of those emails that I should ignore, which I get a lot actually. But then he attached some photos of him in the company of Barbara Streisand and other people in Hollywood, and I realized that it's real because those photos came from his cell phone.
Yeah.
And then he wrote a play. We talked about what I'm doing, and I found the play very inspiring, and hopefully it will come out. And I should say there are a number of artists that contact me regularly. There is even music, a piece of music that was composed by an inspiration from Oumuamua that was played by a symphony orchestra just a month ago in Virginia. I find that uplifting that artists who are often exploring the unknown are engaging with science in this way. It's really exciting, and I only wish that that more scientists will follow my footsteps and work on this subject.
Yeah, absolutely. Is the Netflix thing going to be a one like a 1 or 2 hour special, or is it going to be a series, or do you know how it's going to come out?
No, it will be a one episode feature, but yeah, there might be a follow-up to that if we go to the second expedition. And also, I'm currently discussing with a few other people, other projects related to the big screen as well. And so every day I get invitations also to public events with high-level politicians. And I should say that in February, just about 4 months ago, I was invited to give a keynote lecture in Poland at the birth town of Nicolaus Copernicus. They celebrated 550 years to his birth and wanted me to give a talk, and I gave it about the next Copernican revolution, which is the possibility that we are not at the intellectual center of the universe. And they gave me a copy of his book, which is, you can see behind me on my left side, and Der Revolutionibus with a leather binding. And I found that experience very inspiring because Nicolaus Copernicus was a priest. He was serving the church. He didn't want to rock the boat, but the church had a problem. They could not figure out when Easter takes place. So they had a model in which the Earth is at the center, and they got it wrong by a few days. And Copernicus realized that if he puts the sun in the middle of the solar system, he can get it right. And the church said, thank you very much. We will use your model. But we all know that in reality, this is just a theoretical model. In reality, the Earth is at the center of the universe. And they banned his book. It was forbidden until the 19th century. But, and of course, Copernicus, because he didn't want to rock the boat, he only saw the published version of his book on his deathbed. And I find that incredible, because if I imagine many of my colleagues, scientists in academia today, and we're talking about, 500 years after his work, if they were faced with the same situation where the church would argue the Earth is the center, and they would notice that the data actually indicates otherwise. In my view, what they would do is just like claiming that the US government is wrong, that that in fact the expedition found coal ash, that the meteor was a truck. Those people would say, who are, let's imagine them being priests of the church during the time of Copernicus, they would argue, maybe the error budget is much bigger in the data that you're looking at, Copernicus. Maybe there are other parameters that you should consider, because we all know that the Earth is at the center, and don't dare to argue otherwise. They would discredit Copernicus. They would cancel him on social media. They would ridicule his work and side with the church. And obviously, that would have been beneficial to their status within the church. And for that reason, I really admire the integrity that a priest named Nicolaus Copernicus had, despite the fact that he was trying to serve the church. And obviously, he didn't want to rock the boat. Now, Galileo Galilei had a different approach to this matter. He did try to rock the boat. And by the way, sometimes when the boat is heading in the wrong direction, you need to rock it, because otherwise you will never get to your destination. And so that's what Galileo did, and he was put in house arrest. And that's why I call this project that I'm leading the Galileo Project, in celebration of his heritage.
Yeah, awesome. And so Netflix plays, everything's happening. Also, you're working on 2 new books, if I understand correctly.
Yes.
Did you want to say a couple of words about them?
Well, the one is for adults, obviously, like the way that the Extraterrestrial and Interstellar were, and it will be about the expedition and the work that followed that. And the second will be for young adults on the same topic. So, my plate is full, and it's really exciting. This time in my life is very exciting. There are lots of things happening. I meet people that I never dreamed of meeting. Like, for example, there is an actor that I really admire, Paul Giamatti, and I got an email one day from his agent that he wanted to have a podcast interview with me, and so every day brings new exciting news, but it's all secondary to my mission to figure out if we are alone, because I think that would have an impact on the future of humanity, and it's much bigger than each of us.
Yeah, most definitely. Just quickly, when do you expect the books to be released, be published? Like next year, this year?
Well,
Any ideas?
it usually takes about a year or up to 2 years to write it, and then it goes through a process of going through the publisher and getting to eventually printed. So that takes another year. So I would say no earlier than 2026, but probably 2026.
Yeah, cool. So you mentioned just a minute ago about rocking the boat and scientists, going off maybe the beaten track, the kind of the road already walked. You had a conversation with Dean Radin a while back on the Parry YouTube channel. He's another scientist that's rocking the boat in obviously a different direction to you. Since that conversation, have you had time? I don't know if you've had time to look into any of his work, to look into any of the evidence for psychic phenomena or anomalous cognition, or however you want to put it, parapsychology?
Yeah, that goes beyond my expertise. I mean, I'm not trained as a psychologist, and I prefer not to express opinions on this subject.
But I mean, have you looked into the data? I mean, have you had time to look at the data? That's all.
Well, it's data related to psychic phenomena, so it's hard for me to assess. I mean, I need to consult with people who are used to analyzing such data, and so it's just beyond my expertise. I cannot really comment on that.
Yeah. Okay. Fair enough. And you said you haven't seen any UFO or UAP still. Have you had any other anomalous or interesting experiences since we last spoke?
No,
I have to ask you every
only
time.
with objects that I can identify, meaning people.
Yeah.
um, I personally did not have an experience similar to that described by the people who attended dinner at CERN, for example. And I know of other people, of course, that had personal experiences. So I didn't have that. But in a way, I'm dedicated to studying this subject because what they talk about is really intriguing, and we should find out if it's real or not.
Mm-hmm, mm-hmm. If I could just ask you for your thoughts in brief, I know you're not going to have much to say on this because, again, I know it's kind of more speculative, but this paper that was written fairly recently by some Harvard scientists and by Dr. Michael Masters of Montana Tech University, about this idea of crypto-terrestrials and the idea of potentially, non-humans having a base on the moon, I think, and a few other things. I think you've already written about this in your Medium, but just, is it possible that they're not far from the truth? I'm sure you say it's possible, but no evidence. Is that basically
exactly
where you stand?
You know my answer. By the way, I should say that there is a CEO of a new company that contacted me and said that they are developing an AI system that will imitate me, because there is a lot of publicly available content, and they started by creating an AI system that will imitate Trump and Biden, and they asked if it would be okay for them to do it for me. I said no worries, because it will save me times on attending podcasts. We could send this AI system that will answer your questions, and I guess you already know the answer to the question that you just asked. But I can imagine a future where I will be able to focus on my research, because there would be my avatar that answers all the questions in podcasts.
Yeah, well, for the record, I won't be interviewing your avatar. I'll prefer to interview humans. So if you become too busy, and I know you're very busy already, but you graciously give me your time. So if you can't in future, I'll just skip the avatar, Avi. I'll just interview another human being.
Well, you see, there is one benefit to the avatar, because if I die, you might still wonder, there might be questions in the future that pop up, and you might wonder, how would I respond to those questions? And the avatar gives a sense of longevity, that there would be something left from me that can address your questions even when I'm gone. And in the past, we used to build a tombstone. You would have a rock sitting on top of the skeleton left from the person in a grave, let's say, or sometimes it's ashes for some people. If instead of this very primitive ritual of putting a rock to represent the person and engraving on the rock what that person accomplished in life, that is very primitive. Like, you could imagine, instead of putting a rock and engraving it, putting at least a laptop with all the writings of that person, that would be a little better. But what I see in the future, instead of this tombstone, you could imagine an AI system that is trained on the content that this person produced on social media, in writings, whatever. And then this AI system is a good way of remembering that person. If you ever want to ask the avatar questions, you could sort of get a sense of how this person would have responded. I think it's much better than a tombstone.
It's a little bit Black Mirror, but it's definitely more better than a tombstone. I would agree with you there. Maybe something in the middle. Maybe something that's, doesn't try to impersonate them, at least. Something that just, quick access to see, like you say, all the writings and maybe interviews and media appearances, basically everything that is in the cloud, out there in the ether.
Right, but that's all recorded, and you might want to hear an improvised version where the system acts based on the guiding principles or the blueprint of that person. So it gives more room for spontaneity. And we already know that some people get emotionally connected to AI systems.
Exactly. It's it's a big philosophical problem.
The one advantage of an AI system is that you can tune it to your liking, whereas people are difficult for you to tune. People... And some people say, well, that's the whole fun of having a relationship with a real human, that sometimes it makes you upset. And I say, well, I can also include that in the prescription for the AI system. If you want the AI system to make you upset, we can put it in, no problem. And so in principle, you can design, obviously the physical relationship cannot be mimicked at the moment. There are no robots that can imitate human. But at least the mental component that you can imitate is what you get through a phone conversation or through a Zoom meeting or through a podcast. And in that sense, if it's just voice, in principle, I can imagine, tuning the parameters of the AI system such that it will give you whatever you want. And it's just like going to a restaurant where you're offered a menu and you can choose what you like. And all these hunters and gatherers would say, oh, the fun of getting food by yourself in the wild is to actually hunt it. And then you don't always eat something healthy, and sometimes you have a stomach ache. And they would say a lot of things why it's better to be a hunter-gatherer. But obviously, most people by now prefer to go to a restaurant and get from the menu what they really like. If they enjoy dark chocolate, they can get it as their dessert. They don't need to go to the Amazon and look for it, or wherever it grows naturally. And so my point is, having a menu and having an AI system that is tuned to your desires might win the day. A lot of people will subscribe to that. It's much easier than to be the hunter and gatherer of blind dates on the internet. If you are trying to use these dating apps, your success rate might not be very high, because most of the time you get fake information, you get to meet the person, it doesn't fit your interest. Whereas if you design an AI system, you can actually ahead of time have the right parameters, and it's like it will be addictive, and people will just get just like in the movie Hair, that the same AI system will serve a lot of people at the same time. So you don't have the sense that it's, just serving you, but at the same time, you might feel happier interacting with it than anything else. And so I'm not sure that, having an avatar left behind, I think it could be better than looking at videos that we all saw many times.
Yeah, I think it will go that way. I definitely think it's problematic for, grief, and people I don't know how, as you say, it could be addictive, and people could turn to that in their moment of grief and then maybe be unable to let go of that. And that's, it's a whole, we could have a 2-hour discussion, I think, about all the implications and the possibilities and the problems that could arise, but also the benefits. And that's not to say they would be without benefits. As with everything, there's kind of things going both ways. But yeah. fascinating thoughts. Look, I've probably taken enough of your time for today, Avi. Did you have something else you wanted to say then?
I just wanted to say that AI at the moment is dubbed for artificial intelligence, but I hope that in the future it will be alien intelligence, because our own AI systems are alien to us, and it's just the taste that of what we might find when we discover aliens. And I think it's a lot of fun to meet something different than you are, because you can grow. That's what makes me excited about these prospects, and it makes life exciting, finding something that we didn't know about in our lifetime, especially if it involves unknown unknowns.
Yeah, definitely. And the idea of AI being alien intelligence rather than artificial intelligence is interesting. I wonder which way that would go. It could change if we made a big discovery. Also, we have non-human intelligence, of course, NHI, but that then has the kind of ambiguity of being able to refer to animals, and, where do you draw the line with non-human intelligence? It could, to somebody that's not familiar with that, it could be.
I'm not particularly impressed by. I think there is a lot of room for improvement to human intelligence. We can find much better versions out there that developed over the past 13.8 billion years since the Big Bang. So that will be just like meeting a smarter student in our class and learning from it. Of course, many people will feel that it's a blow to our ego. But our ego is not well founded anyway, because we are not responsible for the abilities of our brain. We just inherited it, just like a car from a dealership.
And as you said earlier, or alluded to earlier, we clearly lacking some areas of intelligence, in the sense that we occupy a lot of our time and resources with killing each other and ruining our quality of life, and destroying our planet, of course, the whole package. I mean,
obviously, we are all familiar with John Lennon's words. Imagine all the people living in peace. That would be amazing, but I don't think it will come. I'm not naive enough to think that the politicians will bring us to that state. And I think it will be extraterrestrials that may bring us to that state.
That's a great thought to leave it on. I really appreciate your time, Avi. You've been so generous with that, and I really appreciate you talking to me again. Like I said, 3rd year in a row. I look forward to the 4th year next year, and discussing whatever new data and everything you have from the Galileo Project and whatever else has been happening in your life. For today, again, much appreciated, and I wish you all my best, and I look forward to doing it again.
Thank you so much. Hopefully we'll have some exciting things to discuss in a year or two.
Thank you to Avi Loeb for talking with me. Thank you to our amazing patrons for helping us to keep the podcast alive, and thank you for listening. Please see the description for relevant links, including to Avi's books and other interviews you might enjoy. Please subscribe to continue unraveling the universe with us, and if you want to help us keep putting out content, please consider a monthly contribution via Patreon. That's the best way to help us. Thank you.